Okay, good afternoon, flippers. This is Maddie with my first flipped video. I'm so excited. You have to be as well, because duh. So our video is 2.3. Our unit title is Logic Lines again, so we're on Unit 2. Our objective for today is I can determine if a set of lines is parallel or perpendicular. And our second objective is I can determine the slope of a line. So you should have both of those by the end of today. Your IXL skills are E5. If you have not done the previous IXL skills for this week, you should do them at this point because you will be so overwhelmed come Friday. Okay, let's go. First, to understand what if a line is parallel or perpendicular, we must understand what slope is because that determines what our lines look like. So let's think back to algebra. We know that slope is rise over run. So remember, that's our change in our x's, the change of our y's over the change in our x values. And if we're thinking about our formula that we should know, we know that it is y2 minus y1 over x2 minus x1. And I'll draw a little graph here so you can see I have a positive slope of a line, and this would be my x values, and these would be my y values here. Okay, let's now look at slope-intercept form. Slope-intercept form is the form of the line when it is written algebraically as y equals mx plus b. And if we go back and think about what each of those letters mean, m represents our slope, b is our y-intercept, and our y and our x can be anything we want them to be. They're just the coordinates that plug into our algebraic formula. Perpendicular lines are when you have two lines and they cross at a right angle. So that picture I have there, that is two lines, and the little square is supposed to represent them crossing at a right angle. Algebraically, we have perpendicular lines when our slope turns into the negative reciprocal. So if you have slope m, it will change to slope -1 over m, which you see on the screen. An example of that is if your slope was 2, it would change to -1 over 2. What this means is if we have slope m sub 1 multiplied by the second slope, which is perpendicular to it, m sub 2, they should always equal the product -1. Parallel lines, our next type of line. Parallel lines will have slopes that are equal to each other. So m sub 1 is equal to m sub 2. So, for example, if you have y equals -2x plus 3, and then you have line y equals -2x plus -8, we know that those are parallel lines because even though they have different y-intercepts, they have the exact same slope. So you know those are parallel. Okay, examples. Are these lines parallel or perpendicular? We have 4x plus y equals 6 as our first line, and then we have y equals -4x plus 8. So great. We need to know if they have the same slope, but our first line is not in slope-intercept form. So we need to come over here, rewrite our line, and then we need to solve algebraically so that we have y on one side because we need it as y equals mx plus b, so y by itself. So what I do first is I take my 4x and I'm going to subtract it. As you see over here, it is now subtracted on that side, so we canceled it out. And now we go down and we have y equals 6 minus 4x, but I still want to put this in the correct form, so I need my x to be in front of my y-intercept. So I'm going to flip it around, and I put my -4 in front of my 6, and I remember that my 6 is positive, so it's -4x plus 6 instead of subtracting, because we know 6 is positive. So we know that -4x is the same slope as the other one, which is also -4. So we have -4 and -4. So those two are actually, those two are actually parallel. So are these lines parallel or perpendicular? And we have -4x plus y equals 8. I know that little negative is written in there, but it's -4x. And y equals -1/4 x plus 6. So, again, one of my lines is not written in the form y equals mx plus b, so I take it over, and I'm going to solve for it algebraically. I am going, since I have -4x plus y equals 8, I'm going to add 4x to both sides to cancel it out. So even though you cannot see it there, I am adding 4x. And I add it over here as well. And then I get my new equation, y equals 8 plus 4x. Again, like I told you before, we want our mx before our y-intercept. So I'm going to flip this over here, and I get y equals, and this is positive, so y equals 4x, and my 8 is also positive, plus 8. So this is my final new slope, or y-intercept form of that. So now, is it parallel or perpendicular? Well, I know that my lines are, whoopsies. Well, just look at that arrow. I know that 4x is actually the negative reciprocal of -1/4. So -1/4 multiplied by 4 is equal to -1. So those are actually negative reciprocals, making them perpendicular. Problem 3, what is the product of the slopes of perpendicular lines? Well, we just saw this. We saw that when we had slope 4 and multiplied it by the perpendicular line slope, -1/4, it was equal to -1. That is actually true for every single slope of a perpendicular line. So M1 multiplied by M2, our two perpendicular slopes, should be equal to -1, always. So now the moment you've all been waiting for, the secret hot question. Are these lines parallel or perpendicular? So look at that, think about what we just did in our examples, and put that in for tomorrow. Also, remember to work on IXL skills E5 and all of the IXL skills you have. Thanks, have a great night, see you guys tomorrow.